Today we're looking at notes DD-2 Arithmetic Series. So remember that a series is the sum of a sequence. So we have this formula here for the sum of an arithmetic sequence, or in other words, your arithmetic series formula. So S sub n, where n represents the number of terms, and then equals n divided by 2 times the quantity a sub 1, meaning that first term, plus a sub n, meaning the last term. Okay? If you need to use the arithmetic explicit formula, it is provided here just so you can refresh your memory. Remember that this is like your jump formula. If you need to find out a specific term in the sequence, you can do so using this formula. All right, so look at number 1. Find the indicated partial sum. So we have this arithmetic sequence here. We assume it's arithmetic just because it's in DD2, but let's check. Okay, to get from -6 to -2, we add 4. To get from -2 to +2, we add 4. And to get from 2 to 6, we add 4. So we notice that common difference is adding 4 every single time to get to the next term. Okay, it wants us to find the indicated partial sum for when n equals 50. So we will go ahead and list what we need and then plug into our formula. So we definitely need to know n is 50, okay, because that goes into our sum formula here. We also need to know what a sub 1 is, that first term. So the first term in this case is -6. We also need to know what the last term is. So in our case, instead of a sub n, a sub 50 would be our last term. And so since we don't know what the last term is, we'll need to use our quote-unquote jumping formula to figure it out. So a sub 50 equals the first term, so again in our case -6, plus that common difference we just found out it was 4, so plus 4, times the quantity n, which is 50, minus, in our case here, 50 minus 1. And if we work this out, you would get 190. So once you have your 3 pieces to the puzzle here for your formula, you can go ahead and plug in. So I do just want to notate that this right here is using our explicit jump formula. Okay, sometimes you won't be provided all of the pieces, and so you must use that jump formula. So let's go ahead and plug into our arithmetic series formula, our sum formula. So S sub 50, since n equals 50, is equal to n, which is 50 over 2 times -6 plus 190. Work that out and you get S sub 50 equals 4,600. So if you add up all the numbers in this sequence all the way up to 50 terms, that's what that n means, how many terms, then you would get 4,600. Okay, let's look at number 2. Find the sum of the first 100 positive integers. So remember that an integer means a whole number, right? However, we're saying 100, first 100 positive, okay? So when we talk integers, that could be negative values, negative whole numbers. However, this is saying positive. So the first positive integer would be 1, and then of course 1, 2, 3, 4, blah, blah, blah. But this is saying find the sum of those first 100 integers. So take 1 plus 2 plus 3 plus 4 plus 5, etc. So let's set up our parts that we need for the formula and then plug in. So n equals 100 because we're going to have 100 terms. Okay, a sub 1 equals 1. That's the first positive integer. And then a sub 100 is equal to 100. All right? And then plugging into our formula, you would get S sub 100 should equal there's 100 terms divided by 2 times the quantity 1 plus 100. So work that out. You get the sum of the first 100 integers, 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100, is equal to 5,050. All right. Number 3, so you're looking at that sigma notation, so a different way of asking the same thing. Notice this is an explicit formula. It is an arithmetic sequence right here, 6n. It's that explicit formula. We have n equals 100, or excuse me, 10 is our lower limit, and 100 is our upper limit of the summation. So what we need to do first is find out the number of terms in between to get from plugging in 10 here all the way to plugging in 100 here, going 10, 11, 12, 13, etc. How many terms are there total in this series that we're going to add? Okay, so to find the number of terms, you're going to take the top, the upper limit, minus bottom, minus that lower limit. So this is like the upper limit minus the lower limit. Okay, and then add 1. So that's how you find out the number of terms. So if you take 100 minus 10, you would get 90. And then you would add 1. So there would be 91 terms in this series here that we're adding, okay? So then we have n equals 91. A sub 10 equals, well, plug in 10. 6 times 10, which is 60. And then A sub 100, plug in 100 here, so 6 times 100 equals 600. Now we have all the pieces to plug into our arithmetic series formula. So S sub, oh, not n, I'm looking at the formula instead of plugging in. S sub 91 equals 91 over 2 times the quantity 60 plus 600. Okay, and remember, you can be using your scientific calculator for this, so you'd type in 91 divided by 2 if you didn't do that in your head. Okay, and then you would get that value, and you would multiply it by 60 plus 600, but you'd want to make sure and add these first before you multiply. So 660 times this value. So S sub 91, I'd make sure, check in your calculator that when you're performing this math that you're getting the same answer as I am, just to make sure you know how to use that scientific calculator for this lesson. Okay, so our final answer is 30,030. Okay, two more. So number 4. Okay, so if you have this summation minus this summation, okay, you're going to obviously find the answer to this summation and then subtract the answer to this summation. So let's practice. So in this case, n equals, so let's talk, this is different from this n, of course. We're talking how many terms in this series. So that would be 30, that upper limit minus the lower limit, 30 minus 11, so 19. Okay, plus 1 would be 20. So n equals 20. A sub 11, because that's our first term in this series, A sub 11 would be 11 when you plug in here. And then our last term would be A sub 30. Plug in 30 for n, and the answer would be 30. Okay, so you would, let's go ahead and work below. So S sub, oh, I keep doing that, S sub n, not n, but in this case 20, equals 20 divided by 2 times the quantity 11 plus 30. And in this case, you get S sub 20 equals 410. Okay, and then here, so this is for this one. Let's work over here for this one. So you would get n equals 10 minus 1 is 9, but then add 1, that would be 10. So n equals 10. A sub 1, that's our lower limit, that's where we start, equals 1. A sub 10, our upper limit, would be 10. And then plug in. Excuse me. So S sub 10 equals 10 over 2 times the quantity 1 plus 10. So then you get S sub 10 equals 55. So of course you're going to subtract 410 minus 55, and you're going to get an answer of 355. All right, so last one, problem from the book. So here is the problem from the book, page 587, number 84. An auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all 20 rows? So this is the teacher edition. I didn't bring a student edition home, sorry. So it has the answer. But let's go ahead and work this out. So it's saying this is the auditorium, here's the seats. That first row is 20 seats, that second row is 21, 22, etc., etc., etc. So let's go ahead and set this problem up. So our n would equal 20, here's why. Read back the problem. So it says an auditorium has 20 rows of seats. Okay, so there's 20 total rows. So that means counting these, 1, 2, 3, 4, 5, 6, 7, 8, it's all the way up to 20. Okay, so n equals 20 because there's 20 rows. All right, and then a sub 1 is also 20 because it says there are 20 seats in that first row. And then a sub 20, we need to figure it out using our jump formula, would equal 20, that's our starting value, plus the difference is 1. Each time we increase by 1 seat for the next row. And then we plug in 20 here because n is equal to 20, minus 1, and this equals 39. So remember again, this is our jump formula, explicit jump formula. Okay, so to plug in and find our answer, you would have S sub 20 equals 20 divided by 2 times the quantity 20 plus 39, and you'd get S sub 20 equals 590 seats total, which we already knew the answer, but check it in your scientific calculator.